So guys, for example 2 says that the velocity of a wave of wavelength lambda on a liquid of surface tension gamma depends on the density of the liquid and is given by the expression below. The expression says v squared is equal to lambda g over 2 pi plus 2 pi gamma out of rho lambda, where g is acceleration due to gravity. Now we are asked to show that the expression is dimensionally consistent. Of course, now you remember we talked of the principle of homogeneity, that for them to say we add these terms to these ones, then that is the evidence enough to tell us that the whole of this bracket, please, the brackets were not part of the original question. The brackets are not part of the questions, of course, but they have no effect there. This means that this first term and these ones, they have the same dimensions. So you can equate with either of the two. You'll still show that this expression of ours is dimensionally consistent. Now, let's begin again. We know that for dimensional consistency, dimensions on the left hand side must be equal to dimensions on the right hand side. But please, I'm using the short form to simplify life here, but when you're answering an exam, we expect you to write these words in full, unless if you've defined them somewhere. So let's look at the dimensions on the left hand side. The left hand side has v squared. So what are the dimensions of v squared? V, they did tell us that v was velocity. So the dimensions of the velocity, we found out that this was L over t. Therefore, what does this mean? This is squared. We open the bracket, we're going to get these dimensions equaling to L squared per t squared. Therefore, those are dimensions on the right hand side. When we move to dimensions on the right hand side, now here I said we take either of these two. You can either decide to get the dimensions of this or the dimensions of that. Let's take this first term. So now it means that the dimensions on the left hand side should be equal to 1 out of pi. I've pulled pi out, 2 pi, simply because 2 pi is a dimensionless constant times the dimensions of lambda g. Now, let's plug in the dimensions of the respective terms. We know that lambda is length, so the dimensions of length are L, and we know g is acceleration due to gravity. So acceleration due to gravity has the same dimensions as acceleration. So we found out that dimensions of acceleration were L per t squared, and the whole thing becomes 1 out of 2 pi times this is L times L, this is L squared, the per t squared. Now, from here, this is evidence enough from the principle of homogeneity. This tells me that the dimensions of this bracket should be equal to the dimensions of this other bracket, and therefore it is true, since 1 out of 2 pi is a dimensionless constant, therefore it is true L squared per t squared are the same dimensions as we had on the left hand side, and therefore we are going to say that since 1 out of 2 pi is a dimensionless constant, comma, the dimensions on the left hand side are equal to the dimensions on the right hand side, and therefore the equation is dimensionally consistent. The equation is dimensionally consistent. Now, let's look at a friend who decided to consider the other second term on the right hand side rather, on the right hand side, we say for 2 pi gamma out of lambda rho. Let's see the dimensions here. The dimensions will be, this is 2 pi into dimensions of gamma out of lambda rho. Now, what are dimensions of gamma? We know that gamma is surface tension, and surface tension is a force per unit length. So, the dimensions of gamma are equal to the dimensions of force divided by the dimensions of length. Therefore, my gamma is equal to mL per t squared out of L. Therefore, my gamma here shows me that the dimensions of gamma is m per t squared. We come to our expression. This becomes now 2 pi into the dimensions of surface tension, which is m per t squared divided by the dimensions of length times the dimensions of density. Density is mass per unit volume. So this is m, which is dimensions for mass, and the per unit volume, which is times the L power minus 3. Therefore, we see m and m cancelling, and therefore we are left with 2 pi is equal to per t squared out of per L. Of course, from the rules of indices, when our L goes up, this becomes 2 pi is equal to L squared per t squared. But we know that 2 pi is a dimensionless constant, just in the case here. 1 out of 2 pi is still a dimensionless constant, and therefore we realize that is true. The dimensions on the left-hand side, this was L squared per t squared, is equal to L squared per t squared, and is true. Whoever used either rule would still get it. Or if you want, you now, after getting the dimensions for this quantity, we can add all of them, and we shall get, this will be 3, or this will be 2.5 pi L squared per t. Now when we sum the two, we still, the things that have to do with pi and the coefficient here are dimensionless constants. Therefore, guys, having looked at this, let's stop here. We shall begin from there in the next session.